Okay, so there's two different types of K that we've talked about thus far. We've got Kc and we've got Kp. Kc involves concentration data. All right. Kp involves pressure data. All right. So the only thing that appears in Kc is going to be, solutions, things in solution, and things that are gases, because they can have a concentration, right? You can have a moles per volume. True? Okay. Kp strictly deals with gases. All right, you'll find they tend to use Kp especially when there's a reaction that's all gases, going from gases to gases kind of thing. But you have to be careful. If they have something in there where they ask you about a Kp, just be careful that you don't bring any solution things in. Or if they have you go from Kc to Kp. All right? Now, let me show you a little something. Let's say we have A gas plus B gas go in equilibrium with C gas and D gas. All right? All right. Now, they're going to ask you, almost guaranteed, they're going to ask you at some point to convert between a Kc and a Kp. And there's an easy way to do it. The hard way to do it would be to take the concentration data and change them all into pressures. Okay? That is a royal pain in the tuchus. And I don't want you to have to fool with it. All right? All right. Now, so let me show you something. If you are given a Kc and asked to go to a Kp, there is a way to do it that makes your life simple. You ready? All right. So, remember Pivnert? Everybody good with that? All right. Now, Walsh, we're going to play a little math. The pressure is equal to nRT over V. True? Okay, here's the next piece. What is, new color, what is moles over liters? Molarity. True? So we can rearrange this and we can go, okay, P equals the molarity times RT. True? You okay with that? Nothing magical. Let me give you a second. Write that down. All right. So let's write our Kp for this reaction. The little a's, little letters are just the coefficients ahead. So if we write the Kp for this, it would be the pressure of C times the pressure of D over the pressure of A times the pressure of B, right? True? Nothing more than that. All right? Now, they would be to the powers of C into the power of D into the power of A into the power of B. True? All right. Everybody good so far? Nothing magical. So all we've got is we got Kp's. If we just had P data, that's easy. There we go. We plug in the P data and we're done. But let's say they give us a Kc. It's easy if you remember something. I don't think they put this on your green sheet, so this is something that might be useful. No, they don't. So this is one that will save you a lot of time if they throw it at you. So what we're going to do is we're going to take that Kp expression and we're going to substitute in this. Okay, now watch. So the Kp expression is concentration of A times RT, all to the A. And we're going to do that over and over again. Concentration B to the RT, to the B, right? No, that's totally wrong. That's on the bottom. Sorry, brain damage. Concentration C to the RT to the C. Concentration B, RT to the B. No magic there, is there? Literally, all I've done is I've started with KP expression. I've taken a simple conversion and I've plopped it in. You good? Nothing magical. All right? Now, if you don't want to write all this down right now and you just want to pay attention, this will be video and it'll be put into Schoology in a few minutes. All right? Because I've been meaning to do that a couple of years ago and I've remembered this year. All right, now watch this. We're going to just rearrange terms. All right? It's still KP. Now, here's what I'm going to do. I'm going to extract concentration of C to the C. And over here, I'm going to put RT to the C. Okay, so these two are multiplied together. That's true, isn't it? I can split that up and I can say, okay, concentration of C, RT, all to the C. I can say concentration of C to the C times concentration RT to the C. It's the same thing. True? We're going to do that with all the terms. Nothing magical. True? So far all I've done is taken KP expression, I've plugged in a rearranged version of P, and then I've broken out terms. Now notice, what is this? This part here. That's KC. Right? Isn't it? Because that's concentrations over concentrations. Concentration products, concentration reactants. So this here thing right here is KC. True? So now we've got KP equals KC, and then we got this thing here. Wait a minute. Let me ask you something. X to the C times X to the D is what? X to the C plus D, right? And so RT to the C times RT to the D is just RT to the C plus D. And if I did X to the C plus D over X to the A plus B, that's the same as what? C plus B, D minus A plus B, isn't it? Isn't that true? Isn't it? Everybody okay with the algebra? I didn't screw that up? Okay. So notice if we take RT instead of that, all we're saying is this is going to be RT, right, to the change in the amount of gas. All right? So it's just going to be the change in the number of gaseous molecules. What? Let me show you. All right? Let me show you what I mean. If I make up, I'm going to get rid of this. Actually, no, I got to. Okay? Watch. I make something up. I got X, 2X plus Y goes to XY2. And they're all gases. Okay? Good? Here's the trick. How many gaseous molecules are over here if they're all gases? Total. How many gaseous molecules? 3. How many are over here? What's here? 1. okay? So how would I do this? If I knew the Kc for that and they asked me for the Kp, all I would do is take and go, okay, Kp equals Kc times RT to the -2. Because the number of gaseous molecules went from 3 down to 1, so if I'm taking the products minus the reactants, 1 minus 3 is -2. Okay? If you memorize this, if they throw one of these at you on the AP, which they have, it seems to me, Brian, you guys had one of those, didn't you, where it was a go from a KP to a KC? Yeah. And that, but that one, yeah, if you don't know that, you're there for minutes trying to take all the pressures, change them all into concentration data. If you have that memorized, you go, boop, 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 done, move on, done. Okay, so all you're doing is counting the number of gases in the reactants, the number of gases in the products, and that's it. Now, which are constants? The 0.00821, I think. I'll check, I'll confirm. All right. Questions, problems, concerns?